So just like I told you, you are to just like I told you, you are to be learning on the topic salts. So our topic for today is supposed to be salt. Salt. So write that down. Salt. I know some of you have done that with their teachers. Korir.
Yes.
Darius, Korir.
Yes.
Good morning.
Good morning.
Did you get what I said?
Yes.
Oh, so we are learning on the topic salt. Nilishafanya hiyo?
Okay.
Hmm?
No.
You had notes.
Yes.
Let me just keep them busy kidogo. So that's what we'll be learning. I want you to look at the specific objective of that topics. The ones I hope you can see the screen, so go through that. Let me just do something. Hello. I hope you have you've gone through that, and we can now proceed. You can unmute yourself so that we can have some effective communication. Try unmuting yourself. Try unmuting yourself. I'll just give you permission now. Good. There is correct pamoja.
Yes.
Yeah, so we talked about you've seen the central objective of the topic, like salt. We know you have to know the meaning of the salt, the type of salt. And you can see that acidic salts, double salts. Then you have to know the solubility of salts, the salts of sulfates, the salts of chloride, the salts of nitrates, carbonates. Okay, solubility of bases in water. So as time goes by, we get to know what you're supposed to know on that topic. So Jack Mutuma. Mutuma, are we together?
Yes.
Huh?
Mm.
Okay, so what is a salt? Let us define salt. What is a salt? What is a salt? So I want you to know that when in your Form 1 work, in your Form 1 work, when you in your form of preparing hydrogen gas, reacted hydrochloric acid with which metal? We reacted HCl with which metal? Form 1 work. How did we prepare hydrogen gas in the lab? How did we prepare hydrogen gas in the lab, Alex Macau? Macau, Alex. Yes. Boniface Odhiambo, how did we prepare hydrogen gas in the lab? Yes, David Gashema.
Reacting zinc with hydrochloric acid.
We reacted zinc with hydrochloric acid, and what were the products?
We had zinc 2 chloride and hydrogen gas.
We have zinc chloride plus hydrogen
Gas.
Zinc chloride plus hydrogen gas. We had zinc chloride plus hydrogen gas. So that zinc chloride that you formed there was an example of a salt. So some salts can be prepared when you react an acid and a metal. So some salts can be prepared when you react a base and an acid, while some salts can be prepared when you react individual elements themselves. You understand? So what is a salt? What is a salt? Write this down. Say that. Shukrani says it. Say that a salt is a substance formed. A salt is a substance formed when the hydrogen of an acid. Salt is a substance formed when the hydrogen of an acid. Salt is a substance formed when the hydrogen of an acid is replaced. Salt is a substance formed when the hydrogen of an acid is partially or wholly replaced. Is partially or wholly replaced by a positive ion. Is partially or wholly replaced by a positive ion. A salt is a substance formed when hydrogen of an acid is replaced partially or wholly by a positive ion is replaced partially or wholly by a positive ion. So we are defining a salt. So the first thing you're talking about here is the definition of salt. Definition of salt. So, and you said that it is a substance. Those of us who are chatting, I don't know what is wrong with you. I'll simply remove you from the class and then you give those ones to learn. Okay, pardon, please. Dennis, I'll pardon for you. That's okay. So a salt is a substance formed, substance formed when the hydrogen of an acid is partially or wholly replaced. Yes, Ryan.
Yeah, hapo kwa definition ya salt. In the definition of salt,
Yes.
unaweza pata mark ukisema hydrogen peke yake ama unafaa kusema hydrogen ions.
I said you can't say hydrogen peke yake because the ions which are present there are the hydrogens are in ionic form. They're in aqueous state, so they have to be in free form. So you have to say that the substance formed when the hydrogen of an acid is partially or wholly replaced by a positive ion. When you talk about a positive ion here, when you talk about a positive ion here, this can be a metal ion, a metal cation, or ammonium radical. So
Yes.
when you have the hydrogen of an acid, when you have HCl, when you react zinc plus HCl, for example, we are saying when you have zinc, zinc plus HCl,
zinc chloride plus
Zinc 2 chloride plus hydrogen.
So but plus HCl will have zinc 2 chloride. Zinc 2 chloride plus hydrogen gas. So, hydrogen gas. So that is just a minute.
Favorite carbon.
Favorite carbon.
Your equation speaks of zinc carbide and not chloride.
This means hydrogen chloride or zinc plus carbon. Kind of shady stuff.
So we say that is the definition of a salt. So we say this is supposed to be hydrogen gas. Now, if you look at this particular reaction, what has happened? The zinc metal has replaced the hydrogen in the hydrochloric acid, so that we have what? Zinc chloride. We're supposed to, this is wrong. This name is wrong. Yes, Dennis. Muhehe. Dennis.
Oh, I was telling
Write
you
those
equation
notes.
was wrong.
Yeah, it was wrong with the product side. Huh?
Yeah.
It is wrong because we are supposed to have zinc plus HCl, supposed to be zinc plus the HCl, giving us zinc chloride plus hydrogen gas. Is it okay now, Dennis? Zinc chloride plus hydrogen gas. Okay, that is supposed to be a capital. So if you look at what is happening here, we have what the hydrogen in the acid. What has happened? It has been replaced by the zinc ion. So that we have got zinc chloride plus hydrogen gas. So we are talking about a salt. A salt is being formed here. We are forming a salt as a result of displacement of an hydrogen gas from an acid. When you have another example, for example, we can have something like zinc plus sulfuric acid. That will give us zinc sulfate plus hydrogen gas. So anytime you react as an acid and a salt, an acid plus a metal, then you get a salt plus hydrogen gas. So there are different methods of preparing salts. Jack Mutuma, David Gashema.
Yes.
Okay. Did you get what we said?
Yes.
Natupata?
A question.
Yes.
Yes, ask.
Can you also say that a salt is an ionic compound formed when the cation from a base? A salt is an ionic compound formed when the cation from a base combines with an anion from an acid.
Cation from a base.
Combines
See,
with an
a
anion from an
base
acid.
cannot have. You see, a base cannot have a cation. Sometimes when you have sodium hydroxide, that's when you can talk about the cation, because in that case, we'll have, for example, we're talking about, I want to please in here, we're having an example like sodium hydroxide. When you have sodium hydroxide, okay, plus HCl. Depend any Davis.
Sodium chloride.
And what?
Yes, Boniface.
Sodium chloride and water.
Boniface
Sodium
Odhiambo.
chloride plus water.
Chloride. Sodium chloride. Sodium chloride plus water. Plus water. Send you.
Yes.
Plus water. What has happened here? The salt we are having here. Salt we are having here is that of sodium chloride. Because you know water is a neutral compound. Is that right?
Yes.
So if you look at the reaction between sodium hydroxide and HCl, it gives us sodium chloride plus water. So what has happened here? The cation from the base. Obutu, what's the problem? The cation from the base, which is sodium, is the cation here, has reacted with the anion, which is the chloride here. So this is called a neutralization reaction. A reaction between a base and an acid, giving a salt plus water. You understand? So in this case, the cation from the base, the sodium is the cation here, it has a positive ion from the base, has reacted with active ion, which is chloride here, to give us sodium chloride plus water. Again, this is now a method of preparing salt. So I would want you to stick to the definition of a salt as a substance formed when the hydrogen of an acid is partially or wholly replaced by a positive ion. This positive ion can either be a cation from a metal or an ammonium radical. Ammonium radical is written as MH4, H4+. Obutu, you seem to be having some question. Can you continue? So, yes, Adam, Gitari.
Pardon, teacher, please repeat your definition of assault. You were not clear.
But I just written it on the notice board. You didn't, on the whiteboard. You didn't see that. I said a salt is a substance formed when the hydrogen ion of an acid is replaced partially or wholly by a positive ion. A salt is a substance formed when the hydrogen ions of an acid is replaced partially or wholly by a positive ion. Yes, Adam?
Yes, I've gotten you.
Okay, so that is the definition of a salt. So we look at the types of salts now. Types of salts.
Yeah, I know. Now go.
Types of salts. Types of salts. That's what we're looking at next. Types of salts. Can we name them? Now, before you name them, what will help us determine the type of salt is whether all the hydrogen of the acid has been replaced, the method that has been used to prepare that salt. Okay. If all the hydrogens of ions of an acid has been replaced, then we talk about a normal salt. So say that there are 4 types of salts. There are 4 types of salts. There are 4 types of salts. Yes, Adam. Yes. Nakwambiaje? Yes, Adam, guitar, your answer up.
No, they're not. Oh, sorry.
The Shema, David.
I wanted to name the salts, the types of salts.
Okay, please do.
Normal salts,
Normal
acid
salt,
salt,
good.
acid salts,
Acid salt, excellent.
basic salts,
Basic salt
and double salts.
and double salt. That is good. And double salt. And double salt. That is very good. That is very good. So, like Gashem has told us that we have got 4 types of salts. We have got 4 types of salts. There are 4 types of salts. Number 1, normal salts. Normal salts. Number 2, we talked about acid salts. Acid salts. Number 3, we talked about a basic salt. Basic salts. And number 4, we talked about a double salt. So those are the 4 main types of salts: normal salt, acid salt, basic salt, and a double salt. It does not mean that there are some salts which are abnormal. No. When you say an acid salt, it doesn't mean that that the salt is made from an acid. No. When you talk about a basic salt, it doesn't mean that the salt is made from a base. No. And if you talk about a double salt, it doesn't mean that the salt is double. No. So those names are derived based on how, maybe 1, the salt has been prepared. Number 2, whether all the hydrogen ions of the acid have been replaced. And number 3, the composition of that salt. Like we said before, that a salt is a substance formed when the hydrogen ion in an acid are wholly or partially replaced by a positive ion. So when you talk about hydrogen ions of an acid that are wholly, it means they can be partially replaced or they can be fully replaced. And you know, whatever makes something to be acidic is the presence of hydrogen ions. So if these hydrogen ions are not fully replaced, then this salt is going to be acidic. This salt is going to be acidic. So there are 4 types of salts: normal salt, acid salt, basic salt, and a double salt. What is a normal salt? What is a normal salt? What is a normal salt? Yes, David Gashema.
These are salts which do not contain hydrogen atom.
That is very good. Salts which do not contain hydrogen atoms. Salts which do not contain hydrogen atoms. So, we are talking about normal salts. Normal salts. And we have said that normal salts, say these are salt, is a salt, is a salt, a salt that does not contain any replaceable. Sorry, that salt that contains a salt that contain, okay, a salt that does not contain any replaceable hydrogen atom. Salt that do not contain replaceable hydrogen atom is called a normal salt. It's called a normal salt. A salt that does not contain any replaceable hydrogen atom is said to be a normal salt. So that when you react, when you take zinc plus hydrochloric acid, it will give you zinc chloride plus hydrogen hydrogen gas. So in that reaction, in that salt that has been formed, you don't see any hydrogen ion in that particular salt. So, yes, Austin, Sechele. Sechele, please. Austin, you have your hands up.
Yes, I wanted to give the definition of an acid salt.
Let's define it, please.
Yes. An acid salt is
Define it.
an acid salt formed hydrogen ion and acid partially replaced.
Partially replaced. That is very good. That is very good. Yes, Ryan Junior.
Sir, I wanted to ask, what do you mean by saying
Yes.
what do you mean by saying that the salt
Wanted to
does
ask?
not contain? What do you mean by saying that the salt does not contain any replaceable hydrogen atom?
The salt does not contain any replaceable hydrogen atom. The class is on. Just enable video up. Huh? Sorry? How I shall get there? So hapo na enable video na continue to share screen. It's the network. The one naona na regulate hapa supposed to be here. So if you want to share something, just continue. Ryan.
Yes.
When I say you are replaceable, you see, when you have something like zinc, zinc plus H2SO4. Which acid is that? Supposed to give us zinc sulfate plus hydrogen gas. Is that right? Zinc, please don't write that down. Zinc plus sulfuric 6 acid. Zinc, don't write that down. Zinc plus sulfuric 6, this is an example. Zinc plus sulfuric 6 acid will give us zinc sulfate. Will give us zinc sulfate. Zinc sulfate plus hydrogen gas. Tuko pamoja? Warren Kiprono. So if you look at this particular salt here, Ryan, look at this particular salt I'm highlighting. You don't see any hydrogen ion in it. It means all the hydrogen in this sulfuric 6 acid were replaced. It means that all the hydrogen ions in this acid were replaced. So we say that a normal salt is a salt that do not contain any replaceable hydrogen ion. In the salt itself, are you seeing any hydrogen ion? There is no hydrogen ion in that particular salt. So I'm saying that this salt is called a normal salt because it has got no replaceable hydrogen ion. It cannot react with any other thing to give us any other acid. So it is a normal salt. Are we together?
Yes.
Ryan?
Yes.
Yes.
Oh, that is good. So we continue. Examples of normal salts. Examples of normal salts. Number one, you can have sodium chloride. You can have sodium chloride. Sodium chloride is an example of a normal salt. Number two, you can have potassium sulfate. You can have potassium sulfate. Potassium sulfate. Potassium sulfate. You can have sodium carbonate. You can have sodium carbonate. You can have calcium nitrate. Calcium nitrate. And now calcium nitrate. So these salts are neutral in aqueous states. Yes. Iko tu sawa. Mwanafunzi anaongea sasa, that's why you can see anakuja kwa screen, but hizo screen hii ni ya Chrome, nikwambia hii Chrome tu ni ya Chrome. Lakini how comes it's key? Is a network problem. There is a thing I'm telling you.
Sure, your mic is muted.
Oh, Nani, Victor Gidua. I'm saying sodium ethanoate. Sodium ethanoate may not be considered a normal salt in hydrogen still in it, like CH3COH. So it is not a normal salt. That is an example of an acidic salt.
But in Get It Right chemistry, it says that sodium ethanoate contains 3 hydrogen atoms, but it is classified as a normal salt because the hydrogen atoms are not acidic hydrogen.
When you look at this salt here, you see we have what sodium and sodium reacts with CH3 COOH. Okay, that is a weak acid. Okay, that is a weak acid. So if these hydrogen ions, these last hydrogen ions, are fully replaced in that salt, then it will give us CH3 COO and hey, that is what they're calling sodium ethanoate. So you can see in this scenario, the hydrogen ions in this particular, the hydrogen ions, there were hydrogen ions here. And those hydrogen ions have been replaced fully by sodium. So we consider this salt now, this salt here, the salt I've written the equation for, we consider this salt to be a normal salt because all the hydrogen ions which were there, all these hydrogen ions have been replaced by the sodium. So this one is a normal salt. But if these hydrogen ions, don't look at these ones here, look at the last hydrogen ion. If these hydrogen ions were not replaced by sodium ions fully, like we can have something like sodium hydrogen sulfate, sodium hydrogen carbonate, sodium hydrogen phosphate. Those are now examples of acidic salts. Are we together?
Yes.
Any other question? Then you can go to the next thing, you can define acidic salts. Yes, Gashem?
These are salts that contain a replaceable hydrogen atom.
Salts that these are salts that contain
replaceable hydrogen atom.
Hydrogen atom. Salts that contains replaceable hydrogen atoms. Salts that contain replaceable hydrogen atoms. Salts that contains replaceable hydrogen atoms are acid salts. Salt that contains replaceable hydrogen atom. Examples of acid salts. Yes, David.
Sodium hydrogen carbonate.
Sodium hydrogen carbonate. Another one.
We have sodium dihydrogen sulfate. Sodium dihydrogen phosphate.
Sodium dihydrogen phosphate.
I just have two examples. We have potassium sulfate, potassium hydrogen sulfate.
Those are examples of acid salt. So if you look at those examples, that's a screenshot. This, yes, two participants have raised their hands. Yes, Boniface. Ian Mugambi.
Potassium hydrogen
Unmute yourself
sulfate.
and talk, please. Potassium hydrogen sulfate, that's okay. Clinton Joroge.
I have a question.
Clinton. Yes,
Yes, I
Ian.
have a question.
Ask, please.
So, because sodium hydroxide has a hydrogen in it, why is it not an acidic salt?
You just said sodium hydroxide. Sodium hydroxide has got hydroxyl ions and not hydrogen. Hydroxyl ions. Sodium hydroxide. Sodium hydroxide. Hydroxyl ions. They're not hydrogen ions. So. Ian, did you get me? Ian, did you understand that? Sodium hydroxide has got hydroxyl ions, not hydrogen ions. You can write those examples there. You can see them there, sodium hydrogen carbonate, sodium hydrogen sulfate, sodium hydrogen phosphate. And then put that NB down. Write that NB down. So we said we have talked about those of us who are making noise in the background, please give us some ample time. So examples of acidic salts. Number one, we talked about potassium hydrogen sulfate, potassium hydrogen sulfate. We talked about sodium hydrogen sulfate, sodium hydrogen carbonate. We talked about number three, calcium hydrogen. Sorry, not calcium. Sorry, don't write that down. We talked about sodium hydrogen phosphate, sodium hydrogen phosphate. Talks about magnesium hydrogen carbonate. Magnesium hydrogen carbonate. Yes, Ryan Kim.
Sodium dihydrogen.
Di means two hydrogen. Yes, sodium hydrogen carbonate is still okay. There is di means, you see, sodium hydrogen sulfate and sodium dihydrogen carbonate are different things. So sodium dihydrogen sulfate and sodium hydrogen phosphate, those are all acidic salts. You can add that an example, another example. Sodium dihydrogen phosphate, still the same thing. Sodium dihydrogen phosphate, still the same thing. I was seeing two hands. There were some two hands raised. They have lowered their hands, all of them. That is good. We continue. So those are examples of acid salts. I want us to put an NB down there and say, put an NB and say that these salts are, they have acidic property due to the presence of replaceable hydrogen ions. They have acidic property due to presence of hydrogen ions. So what will be the effect of a litmus paper? What will be the effect of a blue litmus paper placed in, yes, Haji? Haji, Hawa, Haji, Isa.
Yes, Ma'am.
Yes, ask your question. I'm seeing your hands are raised. Please talk. Okay. Gashema?
The effect on a litmus paper, a blue litmus paper will turn red, and the red litmus paper will remain red.
That is good. So a blue litmus paper will turn red, and the red litmus paper will remain red, showing that the salt is acidic. What about neutral salts? What is the effect of a litmus paper on neutral salts? Someone? Yes, David?
No effect. They have no effect.
No effect. because they are neutral in aqueous state. Now I'm wondering if David is not a student in this class. We are so many here. Some of us are just sitting there relaxing. Robert Mwambaki, Robert. Robert. Collins Nderetu.
Yes.
Define for us a basic salt.
Basic salt is a salt that contains hydroxide ions.
Salt that contains hydroxide ions. Yes, Dennis. An example of a basic salt.
Sodium hydroxide.
Sodium hydroxide. No. Sodium hydroxide is not a basic salt. Another one. So we define basic salts. Define basic salts.
Basic lead 2 carbonate.
Basic lead 2 carbonate, that is good. Another one.
Basic copper 2 carbonate.
Basic magnesium chloride.
Basic magnesium chloride, that is good. Basic salts. So you say that these are salts. These are salts that contain hydroxide ions. Salt that contains hydroxide ions. So salt that contains hydroxide ions. Salts that contains hydroxide ions. Salts that contain hydroxide ions are said to be basic salts. Examples.
Basic magnesium chloride.
That is good. Basic magnesium chloride. Basic magnesium chloride. Number 2. Basic lead 2. Basic lead 2. Basic
Carbonate.
Lead 2. Okay.
Basic zinc chloride.
Basic zinc.
Basic copper 2 carbonate.
Basic copper 2 carbonate.
Basic copper 2 carbonate is okay. I hope you now correct the formula of those salts. So we are saying they're basic salts because in them we have got the presence of hydroxyl ions. What about ions? General Moki, that is okay. I've seen you texted that one, so that is a good one. Basic zinc chloride is okay.
What about basic lead 2 carbonate?
Basic lead 2 carbonate is okay. Another one. Na mtu anataka kuchapwa. Boniface Odhiambo.
Basic magnesium chloride.
Basic
magnesium chloride.
Basic magnesium chloride is okay. Ephraim. Ephraim.
Basic carbonate.
That's okay. Baraza Lewis. Brother Lewis, your hands are up. Ave Gitonga. Ave. So, and the last type of salt you want to look at is what you call a double salt. Double salts. Double salts. I want us to look at what you call double salts. Double salts. So a double salt is a salt in which there are two different anion or cation. The salt. Hey, can you mute yourself? You don't want to listen to those stories on the background.
Different anions or cations.
A salt that contains different anions or cations. A salt that contains different anions or cations is considered to be a double salt. Yes, Brian. Brian Deto, I'm seeing your hands are up. Brian Deto, admission 22-2203. David Gashama, you have a question? Adam Gitari, what is wrong with you? My friend, you stop chatting on my inbox, I'll remove you. What has Cleverson done? Concentrate. Yes, David, you have a question?
Yes. Under basic salts, are we supposed to use hydroxyl ions or hydrogen ions? Whereby we say these are salts that contain hydroxide or hydroxyl.
Yeah, hydroxide ions. Hydroxyl, still the same thing. Hydroxide, still the same thing.
Oh, they're the same.
Yeah, so the presence of that hydroxide ion or hydroxyl ion
is
what is making that salt to be
basic.
Okay. The presence of hydroxyl ions is what is making that salt. Yes, you're supposed to write those notes. Whoever is asking, oh, Fortune David, are we supposed to write official notes? Yes, you're supposed to write official notes. They're very official. They're very official. Please write them down. Elias Masharia.
Thank you.
Welcome. Masharia. Your answer up. Could you please ask your question? So there is that is very good, Lewis. Trona is a double salt. Examples of double salts. Examples of double salts. Examples of double salts. Yes, Austin.
Ion ammonium sulfate.
Ion ammonium sulfate, that is okay. Examples of double salts. I think 3 hands are up. Ian Mugambi.
Hydrated aluminium sulfate.
Hydrated aluminium sulfate, that is good. I'm seeing Kim.
Potassium aluminium sulfate.
Potassium aluminium sulfate, that is good. Kate. Oh, somebody using Samsung Galaxy A50s. Rename yourself and give me an answer. Kevin Maina.
Potassium aluminium sulfate.
Potassium aluminium sulfate, that is good. Trona, that is okay. I hope you're writing them down. Ephraim.
Hydrated ammonium ion 2 sulfate.
Hydrated ammonium ion 2 sulfate, that is okay. Another one. Ronald Shem.
Hydrated potassium aluminium sulfate.
Hydrated potassium aluminium sulfate. So you can write them, they're here. Write all of this. These are kuandika zote na their formulas. Write them with their formulas. Somebody has a question? Ronald Shem, you have a question?
Sure.
Yes.
Yeah.
Yeah, I'm getting you. Please ask. Yes.
Is it that most of them are hydrated? Why is it that most of them are hydrated?
Because they contain, most of them contains what we call the water of crystallization. Most of them contains the water of crystallization. Water of crystallization. Because if we make them anhydrous, they'll in powdery form, they will not have crystals, okay? They do not have crystals when they're in powdery form. So you are supposed to be hydrated copper 2 sulfate, hydrated whatever. They're supposed to be hydrated. Another thing are okay, that is okay. So we can continue. Kuna mtu kuna swali? Kuna mtu kuna swali? When writing double salt, is it a must to include the word hydrated? That hydrated is just a name, like we are called, somebody's called Ephraim. It's just a name of that salt. So that when you say hydrated, you simply mean that that particular salt is having some water in it. So yeah. So we can continue. Have you finished writing that down, Dennis? Kuna swali?
Yes, teacher. In an exam format, can we be asked to to write the chemical symbols?
Maybe you can be given the formulas, and then you're asked to giving examples, define. Giving examples, define the following terms: normal salt, acid salt, double salt, basic salt. So if you're giving examples, you to decide whether to write the formula of those salts or to write them in word form. Giving examples,
But
define
you
the following
cannot
terms:
be
normal
specifically
salt,
asked to.
Maybe if you're told to write a chemical equation for a reaction between these and these, that is when you will have to write the chemical symbols. But with Ambiwa, like write the formula of Tron and cannot be told that. Idea no sorrow. How do their formulas come about? How do their formulas come about? The formulas come about as a result of chemical reaction. Like when, for example, the first one, the first one is called calcium aluminum sulfate. Hydrated calcium aluminum sulfate. That means a reaction between calcium and potassium and aluminum sulfate. So here to find about that when you do what we call preparation of salts. For now, just know their names and how they are formed. We have 15 minutes to the end of the class, and I want us to do something here, something small here on nature of salts. Nature of salt. Nature of salts. Nature of salts.
Azara!
Nature of, when you talk about nature of salts, what do you mean? There are some salts like pale nyumbani ukija chumvi kwa meza nje, kesho asubuhi urudi, how will you find it? Will it be still dry the way it was?
No.
Will the salt still be dry?
No.
It will not be dry. Something will have happened. Something will have happened to it. It will not be dry. It will not be dry. So there's some salt. Austin Sechele, what's up? Yes, Austin. Your answer up. Again, they are lower. Nature of salt. So say that salt can be classified into 4 categories based on their nature. Salts can be classified into 4 categories based on their nature. Salts can be classified into 4 categories based on their nature. Number 1, salts can be classified into categories based on their nature. Number one, you can have what we call hygroscopic salts. Hygroscopic salts. Hygroscopic salts. So say these are salts. These are salts that absorb water from the atmosphere. But do not form solutions. Salts that absorb moist water from the atmosphere but do not form solution. Kama tu ile chumvi ya nyumbani. Ukiacha nje, what will happen? Utapata imekuwa wet. but it does not form solution. It does not form solution. Salts that absorb water from the atmosphere, but do not form solution. Okay, e.g.,
Sodium chloride.
e.g., we have anhydrous copper 2 sulfates. Anhydrous copper 2 sulfates. Anhydrous copper 2 sulfates. Number 2, we have anhydrous cobalt. Anhydrous cobalt.
Sodium chloride.
Cobalt 2 chlorides. That is good. Number 3, we have common salts. Common salts, or what we call sodium chloride. Sodium chloride. We have another one called potassium nitrate. Potassium nitrate. Those are hygroscopic salts. So you leave them in the atmosphere, they'll absorb moisture, and then, but they don't form solution. Just like when you're being asked from Form 2, how do you test for the presence of water? When you add few drops of water to anhydrous copper 2 sulfate, what happens? The blue color, the white color changes to what? To blue. So it will absorb that moisture, but it does not form solution. Number 2, second type of salt is called the liquescent salts. The liquescent salts. The liquescent salts. What is a liquescent salts? Are salts that absorb water from the atmosphere. And form solution. Are salts that absorb water from the atmosphere and form solution. E.g., can have sodium nitrate, can have calcium chloride, can have sodium hydroxide, can have iron 2 chloride, iron 2 chloride, can have magnesium chloride, etc. So these are salts. If you leave them overnight in some overnight, you just put them outside, give them some like 3 hours, urudi hapo utapata ni kama imekuwa maji. It is now solution, inakuwa maji. If it was crystals, it now forms what we call a solution. We say they are the liquescent. And now, you see there's a difference here. You can be told to define hygroscopy and the liquescency. There is hygroscopy and the liquescency. Now, the liquescency is the process by which salts absorb moisture from the atmosphere and form solution. While the liquescent salts, the liquescent is different from defining the liquescency. Now, the liquescency is a process. The liquescent is a type of salt. Hygroscopy is a process. Hygroscopic is a salt. You understand? The liquescency is a process by which these salts absorb that moisture. While hygroscopy is also a process by which they absorb that moisture, but they don't form solution. So please always get those two different terms. There is hygroscopy and the liquescent. Hygroscopy and hygroscopic. There is the liquescency and the liquescent. So, Ephraim.
Yes.
Power on. The Bluetooth device is ready to pair.
Is that right?
FM radio.
Somebody is pairing Bluetooth device. FM radio. Fine. Number three, number three, we have what we call a fluorescent salt. A fluorescent salt. A fluorescent salts. A fluorescent salts. It's also the sodium chloride. You see, excuse me, sir. When hygroscopic salt absorb water, will they still be in solid state? Yes, for hygroscopic salt, utaona ni kama zinakaa shiny, zitakuwa zinakaa shiny. Ziko wet, they are wet. Ile chungu umenunua kwa duka, inakuanga dry. If you pour it on the table, you can have crystals separating apart. But now when it has absorbed moisture, inakuwa wet and therefore they stick together. That is hygroscopic salt. They will still be in solid state. But for the liquescent salts, they will be in solution. They are no longer now in solid state. They will be now in solution form. They will absorb the moisture. Now they're in liquid state. They will not be in solid state now. Somebody is also asking on the inbox that, excuse me, sir, Spotlight revision book says that sodium chloride is so the liquescent. Now, there is this sodium chloride in the lab. You know sodium chloride, ile chumvi tunatumia nyumbani is also called sodium chloride, ndio?
Yes.
Ukitoa chumvi nje, ilale nje, kesho utapata imeform solution. Will it form solution? Itakuwa form solution kweli?
No.
I doubt if it will form that, so ignore that spotlight. Any other question? If you have any question, you can always inbox me there. I will always read it. Yes, Adam Gitari.
So it's chair. What if you put it like this, if you put salt in like waters, won't it dissolve?
Also, there are some salts which dissolve in water and some which don't dissolve. We are talking about a scenario where we don't dissolve them in water. You leave them outside in the environment, okay? You have different salts A, B, C, D, and E. Maybe in test tube A, you have maybe common salt. In test tube B, you have sodium hydroxide. In test tube C, you have maybe iron 2 sulfate heptahydrate, for example. Now, if you leave this salt and come back tomorrow, you will find one, ingine imekuwa wet, it has not formed a solution, it is in the solid state. Kuna ingine utapata imeform solution. Na kuna ingine utakuwa uliweka kama iko wet, but sasa iko dry. So the difference, the three nature of salt. Salt can either be hygroscopic, then they can be the liquescent, or they can be a fluorescent. A fluorescent are those type of salts which will lose the water of crystallization to the atmosphere. Just like we were talking about double salts, we said they are hydrated. So if you leave it in the atmosphere and then come back tomorrow, you will find that this salt is now dry. Is it making sense?
Yes.
The salt will now be dry. The salt will now be dry. So we call such salts to be a fluorescent. Such as in spotlight chemistry, that sodium chloride is used to separate the liquescent and hygroscopic. It depends, like I said, that the one we buy at home is called common salt. Ile ya nyumbani. Lakini the one which is in the lab, it can both be hygroscopic or the liquescent, depending on the amount of water in the atmosphere, amount of water vapor, depending on the humidity. Humidity is the amount of water vapor in the atmosphere. So if the humidity is high, sodium chloride can both be hygroscopic or the liquescent. It can form solution when there is too much amount of water in the atmosphere. It can form a solution. But if there is little amount of water in the atmosphere, it is now becoming hygroscopic. So you classify salts, sodium chloride, as the liquescent or hygroscopic isn't a problem because it depends on the amount of water vapor in the atmosphere. So Vincent Kinywa. Love those questions. Keep them coming, at least you get to know. Now, efflorescent salts are salts that lose their water crystallization. Crystallization to the atmosphere. lose their water vaporization to the atmosphere. For example, we have iron 2 sulfate. Iron 2 sulfate. Iron 2 sulfate. And 2 sulfate. Heptahydrate. Heptahydrate.
Hizo za kuride bike.
Hydrate.
Then hizo za brick.
Sodium sulfate, decahydrate.
Hizi ni raba huku chini.
Sodium sulfate.
Hii ni plastic.
Decahydrate. Decahydrate. So these are salts. Okay, their formulas are as follows. Iron 2 sulfate is written as this: Fe S04 heptamine 7.7 H2O. Then here sodium sulfate is sodium sulfate decahydrate will be Na2SO4 dot 10 H2O dot 10 H2O. So those are what you mean by fluorescence. Fluorescence, what I've said, are salts that lose their water of crystallization to the atmosphere, e.g. iron 2 sulfate, sodium sulfate, decahydrate. So we are calling them that because when you leave them in the atmosphere, yes. Now I'm seeing we are running out of time. We are running out of time, and I want to write the following question down. Okay, the following question down. First assignment.
I the only one who watches movies.
Business that will be tricky unless Joanne behaves. I don't know.
Your assignments, please.
Okay.
I'm seeing your hands, David, are up. Please ask.
Okay.
Another example. Sodium carbonate.
Okay.
Sodium carbonate decahydrate equals to
And a fluorescent salt.
And a fluorescent salt, yeah, that is okay. Define the following terms. I'm giving your assignment as the following. Just a minute, I'm sharing the assignment. Hey, we got
smoke.
Zawadi. Zawadi, you have a question?
Anyway, unaniumiza bana. Na utoi kitu yangu.
Ingine nikipata.
Alan, this might be your last class supper. So you stop making those loud music at the background. Be serious. So in case you have a phone, you can just screenshot. Unapiga picha. Mnaona your assignments?
No.
No.
Iko wapi?
Yeah, we can.
The name
Jina assignment
assignment.
iko hapo.
Jina assignment pekee.
Is it visible?
Very happy. Yes, what do I tell Joseph on your behalf? Atafute wakulima wa kuchukua viazi ya 10 bob.
Please, kama uko na picha au uko na simu, piga picha hiyo assignment.
Vines, you know some of them
can inbox me your answers later.
You know some of them feed to animals.
Yes. Yes. David, what's the problem?
Haionekani vizuri.
Haionekani vizuri.
Okay, I will send to your inbox then. I will send to your inbox.
Yes.
I will send to your inbox.
Thank you.
Haiko clear.
Kuna mtu ako na swali? Ndatumana. So we can end it there.
Yeah.
Hey.
Tell us send it.